The idea of multiplying and dividing rational expressions is very similar to simplifying rational expressions. But before we get into that, we have to remember how to multiply fractions and how to divide fractions. And I'm going to start with multiplying fractions. When you multiply fractions, you're just multiplying the numerators and multiplying the denominators. No common denominator, nothing fancy. So if you have rational expressions and you're multiplying, you're going to start off by factoring, just like with simplifying, and then we put our numerators together and our denominators together, and then start canceling out any common factors. And then, just like with simplifying, we have to remember restrictions. And the restrictions come from the denominator because we know we cannot divide by 0. So let's start with our first one. And for our first numerator, we have a complex trinomial, so I'm going to do decomposition. You can also do crisscross or any method that works for you. But for decomposition, I want two numbers that have a product of 2 times -4, which is -8, and a sum of -7. So my two numbers are -8 and 1. So I'm going to decompose that middle term into those two magic numbers, -8x, +1x. And now I pair up and get a common factor from each pair. And in my first pair, I can factor out a 2x so that I'm left with x minus 4. And in my second pair, I have to factor something out. So I'm going to factor out a +1, and then I get x minus 4 again. And that's how I know I've done the decomposition correctly. Now I can take out my common x minus 4 bracket, and I'm left with 2x plus 1. So now let's write that in our first rational expression. So for the numerator, I will write x minus 4 and 2x plus 1. And for the denominator of my first fraction, I have a common factor. And that common factor is a 4x, and I'm left with x plus 6. Now notice I did just create one very long fraction, and that's because when I multiply the second rational expression, the numerator is just going to stay in the numerator with the first rational expression and the denominator with the denominator. So x squared minus 36, that is a difference of squares, which becomes x plus 6 and x minus 6. And for the next one, we have another common factor, and that common factor is just an x. And I'm going to put it in a bracket, and then I'm left with 2x plus 1. Now I start looking for any common brackets or common monomials. And what I notice is that I have 2x plus 1 in both the numerator and denominator, and I have x plus 6 in the numerator and denominator. And now I can write my leftovers. So I have x minus 4 and x minus 6 left in the numerator, and in the denominator I'm left with 4x and x, which I can simplify to 4x squared. And now I write my restrictions. And just a reminder, the restrictions come from the original factored denominator. And I'm going to have a few. So from 4x and x, it ends up being the same restriction, but I will show it. I set 4x equal to 0, and when I divide both sides by 4, I get x equals 0. I set x plus 6 equal to 0, bring the 6 over, and I get -6. I set my third bracket, which is x equal to 0, so that's the same overlapping restriction as the first one. And finally, I set 2x plus 1 equal to 0. And this one takes an extra step here because we bring the 1 over, it becomes negative, and then we divide out the 2 to get -1/2. So our restrictions are x cannot equal 0, -6, or -1/2. And that's for multiplying. You factor, you put your numerators together, your denominators together, cancel things out, write your restrictions. Now for dividing, there's one tiny tweak. And that is when you divide fractions, you have to turn the division into multiplication by taking the reciprocal of the second fraction, which means your denominator is now going into the numerator and the original numerator is going into the denominator. So we will actually have more restrictions, but we'll deal with that in a little bit. But for now, let's take the reciprocal of the second fraction to turn that division into multiplication. So I have x squared plus 6x minus 16 over 2x squared plus 5x plus 2 times x squared plus 6x plus 8 all over x squared minus 64. And now I want to make a little note here. We know that this is a denominator for the first fraction. We can clearly see that this is a denominator. However, the x squared plus 6x plus 8, it used to be a denominator, which means once we factor, we will have to take restrictions from that expression as well. So I'm just going to highlight them right now so that we don't forget about it at the end. But let's start with factoring. And for the numerator of the first rational expression, we have a simple trinomial. So we need two numbers that multiply to negative 16. So a product of negative 16 and a sum of 6. And those two magic numbers are going to be negative 2 and positive 8. So I can rewrite that trinomial as x minus 2 and x plus 8. And now for our first denominator for our first rational expression, it is a complex trinomial, so I have to do decomposition. So I need two numbers that are going to give me a product of 2 times 2. So I'm just going to do it below. A product of 4 and a sum of 5. So those magic numbers are 4 and 1. So I'm going to break down that 5x into 4x and 1x. And now I pair up, and we can factor out a 2x from our first pair, and we're left with x plus 2. And we can factor out a positive 1 from the second pair, and again, we're left with x plus 2, which means our factored expression is x plus 2 times 2x plus 1. So now I can go up and rewrite this new factored expression in my denominator. And now for our second rational expression. In the numerator, I have another simple trinomial. So I need two numbers here that have a product of 8, but a sum of 6. And those magic numbers are 4 and 2. So I can write x plus 4 and x plus 2. And finally, our last denominator, x squared minus 64. That is a difference of squares. So x plus 8 and x minus 8. And I am going to re-highlight those expressions. So our denominators fully highlighted for our restrictions, and our original denominator for the second fraction became x plus 4 and x plus 2. Now I'm going to cross things out that are common. The x plus 2's are common, the x plus 8's are common, and that is it. So I can write my simplified expression. X minus 2 and x plus 4 in the numerator, 2x plus 1 and x minus 8 in the denominator. And now I write the restrictions from everything I highlighted. So from the x plus 2 bracket, negative 2 is a restriction. From the 2x plus 1 bracket, negative 1/2 is a restriction. And if you'd like, you can set that bracket equal to 0 and isolate for x. For the x plus 8, negative 8 is a restriction. For x minus 8, positive 8 is a restriction. X plus 4, negative 4 is a restriction. And the x plus 2 bracket in the numerator that is highlighted, I already have the negative 2 restriction, so I don't have to write it twice. So division will become the same process as multiplication. You just have to remember that you have extra restrictions on the original denominator as well, which has now moved into the numerator.